Hi guys, this is Ashok Reddy. Today we will discuss JVM Architecture block diagram. Okay, first of all, JVM having four components is there. First one is Class Loader Subsystem. Second one is Runtime Data Areas. Third one is Execution Engine, and fourth one is Java Native Interface. Okay, this is the JVM Architecture block diagram. First one is the Class Loader Subsystem. Second one is runtime data areas. It is also called as memory area. Third one is execution engine, and fourth one is Java native method interface. Okay. Then class loader subsystem. Class loader subsystem, it will take the class file and load the .class file. Okay. Class loader is a class. It is responsible to perform below three activities. What are the three activities? Loading, linking, and initialization. Okay. Then whenever class is whenever .class file is loaded into class loader subsystem, this class loader subsystem having three activities: loading, linking, and initialization. What is the purpose of purpose of loading? It take the class file and store into method area. Okay, in this method area we have three types. Okay, we have to perform three types. What is the three types? Bootstrap class loader. Second one is extension class loader. Third one is the application class loader. First one is class loading phase. What is the class loading? Contain three types of class loader for loading core Java API classes and user defined classes. They are Bootstrap class loader. Bootstrap class loader is responsible to load core Java API from Bootstrap class path. That is from JDK, JRE lib, rt.jar, under lib, rt.jar is there. Okay, you can check now. This is the lib. You can check the rt.jar file. Yeah, this is the rt.jar file. Then you can open that one. Please don't skip this video. I'm going to explain each and every point shortly. Okay, it will take time. Same. Okay, scroll. Yeah, you guys can see under rt.jar available all the Java API. Okay, like core Java API, IO, lang. These are the packages. Okay, all the packages are available in rt.jar file. Okay, then same path available in or extension.jar also. I have to show you. This is extension jar. This under extension jar, this is the jar files. Okay, it is responsible to load core Java API classes from Bootstrap class path. That is from JDK JRE under lib.jar cell available. Extension class loader. Extension class loader is responsible to load user-defined classes or Java library classes from extension class path. Already I told you extension class path also available in and lib only. Okay, under lib so many jars is there. Under jar I will tell you these are the extension under extension path available so many jars, right? In these jars available, what are the available user defined classes or Java library classes from this extension class path. Okay, then note this extension class loader is also called a platform class loader in Java 9. Okay, it is renamed. Then third one is application class loader. Application class loader is also called a system class loader. System class loader, it is responsible to load user-defined classes from application class path. It will load classes from current working directory or from the folder configured in class path environmental variable. I will show you whenever whenever you guys can install the Java installation, once Java installation is done, you can set the class path. Correct na? Under this is the advanced system, under advanced system environmental variable is there, right? Under environmental variable, in this system variable, you can set the class path, right? You can set this class path. Okay. Then now what we are discussing as of now, these are the whenever .class file is loaded into class loader subsystem, we have three activities is there. One is the loading, linking, initialization. What is the purpose of loading? Whatever given .class file is what is the purpose of loading? Given .class file is load and stored into method area. We have in this loading, we have three activities is there. Behind we have three activities there. What are the three activities? Bootstrap class loader, and second one is the extension class loader, and third one is the application class loader. Already we discussed as of now. Okay, then this is the class loader subsystem architecture. Class loader subsystem architecture. This class loader subsystem, it will check here given class. It will class loader subsystem check whether bytecode is given bytecode is available or not in method area. If it is there, if it is there already loaded, then you can use that already there, then you can use that bytecode. Okay. If it is not available, in method area, class loader subsystem, if it is not available in method area, and what will happen? JVM request to the class loader to load this .class file. Okay, I'm going to repeat again. This is the class loader subsystem architecture. First, it will check this class bytecode is available in method area or not. If it is available in method area, you can use the .class file. If it is not available in class loader, then JVM request to the class loader subsystem to load this .class file. Okay, then what will happen? We have, I told you, class loader subsystem, we have three activities. Three is there. Class loader is there. One is the application class loader, extension class loader, and bootstrap class loader. Okay, then application class loader delegate the request to extension class loader delegate the request to bootstrap class loader. Okay, this is the parent delegation algorithm. It is bootstrap class loader is it is follow the class loader parent delegation algorithm. Okay, whenever a class loader subsystem, it will request to the application class loader. Why it is going to request? You can load the bytecode. If it is not, method is not available, this bytecode is not available in method area, JVM request to class loader, hey, class loader subsystem, please load class loader, and then class loader, what will happen? It will say to the application class loader, it delegate the request to extension class loader, delegate the request to bootstrap class loader. These three class loader, it will check class file is available in this path. If it is not available in these three class load, class path, then you will get the java long class not found exception. If it is available in any path, any class path, then loaded into method area. Okay, what I'm going to discuss here, simple. whenever dot class file is loaded into class loader subsystem, this this class byte code in stored in method area. In background, we have three activities is there, three types of class loader is there. One is the application class loader, second one is the extension class loader, and bootstrap class loader. If it is not available in dot class file, is not this byte code, not available in method area, JVM send request to class loader subsystem to load that dot class file. Then dot class file will send the request to application class loader. Application class loader delegate the request to extension class loader. Extension class loader delegate the request to bootstrap class loader. It will these three class loader, it will check whether this class file is available in this class path or not. Okay, if it is available in this class path, then it will load and stored in method area. If it is not available in this class path, you will get the java.lang.class not found exception. Okay, then clear, right? Then next. JVM follow the, already I told you, JVM follow the parent delegation algorithm principle to load classes. Okay, application class loader delegate the load request to extension class loader, and extension class loader delegate the request to bootstrap class loader. This is the parent delegation algorithm. Okay, then if a class loader found in bootstrap path, okay, if class is found in bytecode is found in bootstrap class path, that class is loaded into method area. Okay, method area. If it is otherwise, if it is not available, then here this bootstrap this class file is not available in bootstrap path. Otherwise, send the request to again transfer to the extension class loader. And here also not available, then send the request to application class loader. Okay, application class loader, it is also called as system class loader. Okay, at last, if the system class loader fail to the load classes, if it is fail this loading this classes, then we get the runtime exception. What is the runtime exception? Java.lang.class not found exception. This exception you can see in real time also. Okay, you guys can assume if you are getting this class loader, this class not found exception, you can assume some dependencies are missing, mean then some class file is not there, you can add some dependency. Okay, yeah. Second one is the linking. Once loaded dot class file is loaded into memory area, then second step is linking. What is the linking? We can verify three activities is there. Okay, linking here three activities is there. First one is the verify, prepare, and resolve. Okay, verify, prepare, and resolve. Okay, then you can check what is the verify. This byte code is mean this class file is whether valid or not, and also this structure is correct format is there or not. Okay, that is the verifying the okay, this is the activity. Then second one is the prepare. It will check static variable memories loaded with default value based on their data type. Okay, second one is the what will happen, static variable memory with the default value of static, you allocate the static variable default value of static variable. Okay, then second one is the resolve. All static references replaced with original memory references symbols going to link with the memory location in memory area, nothing but runtime data area. But in whenever your real-time example employee, and this is not going to realize that okay, that all symbolic references replace version of replace. Okay, what will happen? Linking dot class file is whether valid or not. Structure is this structure is correct or not, and mean correct format is there or not. Then second one is where prepare. Okay, in this prepare, what will happen? Allocate the default value of all static variable. Allocate the default value. Okay, then that is the we discuss. Okay, second one is the loading completed. Now we are discussing linking phase. Okay, what is the linking? Three activities. First activity is the verify. What is the verify? It will ensure that binary representation of class is structurally correct or not. That format is correct or not. It will also check whether dot class file is generated by valid Java compiler or not. Simply what is that this activity is verify whether the dot class file structure is correct or not. Okay, valid format is there or not. Okay, then second one is the prepared. It will allocate memory for global static variable, correct now, which are present in dot class static variable will be assigned with default value. I told you whenever class is loaded into, it will verify such a correct format is there or not. Second one is allocate the default value of all static variable from they are defined from top to bottom. Okay, then resolve all symbolic references replace with original memory replaces symbols going to link with a memory location in memory area. Okay, then in this step JVM will change the place with the business link into direct link. Okay, which mean is that while writing a Java program will create object with a real life name such as employee, student, and etc. Machine does not understand the such word. Okay, machine does not understand the such word. What is the employee, student? Does not understand the machine. Okay, so in the resolution step, JVM will assign the memory location for those objects by replacing their symbolic link with the direct link. Okay, then what is the second step we are discussing? The dot class file. The dot class file is whether the dot class file is correct format is there or not. Okay, then structure is correct or not. Then it will allocate the default value of static variable. Allocate the default value of static variable. Okay, then third one is the initialization. What is the use of initialization? All static variable initialization and static block execution will be defined in the order top to bottom. Okay, this guy you can keep in your mind. What is the boost up class loader? Whenever I'm going to repeat again, whenever class is loaded into JVM, JVM whenever dot class file loaded into class loader subsystem, this class loader subsystem we have three activities: loading, linking, initialization. This loading, first one is the loading. What is the purpose of loading? This loading load the dot class file and stored into method area. What is the process of it behind loading? Also three activities is there, correct now? One is the booster class loader, extension class loader, and third one is the application class loader. Okay, then second one is the linking, whether given dot class file is correct valid or not and correct structure is there or not. Okay, then third one is the initialization, all static variable initialization and all static block execution will be execution in the order they are defined from top to bottom. Okay, then runtime. First now class loader subsystem is completed. First one is the class loader subsystem. This is the completed. Now we are going to discuss runtime data area. This runtime data area is also called as memory area. You guys can keep in your mind. runtime data area, it is also called as memory area. Okay. Then runtime data memory, we have method area, heap area, Java stack area. Fourth one is a PC register, and fifth one is the negative method area. Okay. And then first we are going to discuss method area. Method area store the class level binary information, including static variables, static block, and references. Correct? Na? This method area, this class byte code is load and stored into method area. This is nothing but metadata. Okay. Heap area. This method area, we can see static variable initialization and static block in this. Okay. Here, heap area. Heap area, it is used to store object. Okay. But you guys can keep in your mind here two things is there. One is object creation and object initialization. Two things is there. Okay. What is the object creation? Object is when it is going to object creation happen, when it is going to object initialization happen. Okay. Here, this is the one example already I explained previous classes. Okay. This is the okay. This is the example. Okay. 1 minute. This is the example. Example of NSM equal new example of non-static member. This is the object creation and object installation happen. Whenever new keyword execution is, while executing the new keyword, then can allocate the default value. You can allocate the default value. Just see, these are two steps is there. One is the class instantiation. It is also called as object creation. Okay. Second one is the object initialization. Okay. In this, what will happen? Object creation. While executing the new keyword, you can allocate the default value of non-static variable. Okay. You can allocate the default value of non-static variable. Okay. Then second one is the object creation. What will happen? Object creation while executing the constructor. While executing the constructor mean once while executing the constructor, we can initialize the non-static variable. We can initialize the non-static variable like that. Just you can see, we can initialize the actual value. 10, 20 is the actual value. Okay. Just see, 10, 20 is the actual value. Okay. While initializing the object creation, object initialization construct logic is executed. Okay. Just see here. Then you guys understood. My laptop little bit slow. Not 11. Okay. What I'm showing here, here new keyword execution is completed. Here, what I'm told, new keyword execution is completed mean story. Here, new keyword execution is completed mean object creation is complete. Object creation is happening. Correct, na? While executing the new keyword, what is going in? While executing the keyword, allocating the default value of non-static variable. Correct, na? Here, note. Then second note you can see constructor execution is completed mean object initialization is completed. Object initialization completed mean while executing the constructor, you can initialize the non-static variable. Okay. 10, 20 the actual value. Okay. what you have to observe here, non-static variable stored in object. This object stored in heap area. Okay. Then this one is the I am going to explain here. Okay. Yeah. It what I'm telling here, what I'm saying, heap area, in this heap area, it is used to store the object. In this object, we can store the instant variable. Okay, we can store the instant variable. Then the second one is the Java stack area. Java stack area, here we can see method calls and local variable. How many how many methods are calling, those many stack frames are creating. How many methods are calling, those many stack frames are creating. I will show you practically here, diagrammatically. Here one example is there. Just see here, one example is there. This is the example. Here one display non-static method is there. Display is the non-static method. How to call once object creation is done and initialization this is completed, then how to call, by using reference variable we can call to the non-static method. Whenever calling non-static method, what will happen? It will create the stack frame, correct na? Two in this Java stack frame, two threads is, one is the main thread. Under main thread we can see, under main thread we can create the stack frame. Display is the method. Okay, once display method execution is completed, you can destroy this method and control comes to the main method. Okay, then what I'm saying, this method call, whenever how many methods are calling, those many stack frames are executed. Okay, how many methods are calling, how many methods are calling, those many stack frames are creating. Okay, then local variables are two way. We can see local variable also. I will show you. Whenever local variable, where we have to initialize, where we have to declare, local variables are declared in method only, right? Any method, and main method are in method, any method. This local variables are stored in, suppose we have to declare in method, display method, then we can store local variable in stack frames only. Okay, what I am saying, if we are declaring main method local variable, then we can store it in main method. I will show you. Please wait. Think it is slow. Yeah. Here what I'm showing here, I have to declare in main method LM is the local variable, right? LM is it is stored in main thread. This is the main thread. Inside main thread, one more I have to call one more method, that is the add method. This is the stack frame. If I have to declare in inside method, you can create the local variable in stack frame. Okay, but here I am declared local variable in main method. That's why I have to store local variable in main thread. Okay, in this main thread we have to store stack frame. Add is the stack frame. Here you guys can observe non-static variable allocating the default value and initialization is stored in method area. Okay, then non-static variable, three types of variables is there. One is the static variable, third one is the non-static variable, and first one is the static variable, second one is the instant variable, third one is the local variable. static variable you can store in method area, and non-static variable stored in heap area. Nothing but stored in object. Object is stored in heap area. Okay. Then third one is the local variable. Local variable you can store in Java stack area. If you are declare local variable in main method, you can store in main thread. Okay. If you declare a local variable any method, you can store in Java stack frame. Okay. These are the stack frame. Okay. Then yeah. Now yeah. Now you guys can understood, right? Then third one. Sorry, fourth one. This PC register store address of the current execution instruction of thread. Obviously, each thread has separate PC register. I am going to explain deeply. Please focus in your here only. It will when freshers very difficult to understand. Please, if you are not understand, please go through the previous videos. You can understand easily. Who are having experience, definitely it is going to understand. Okay. If you are not understand, please go through the whatever I have uploaded previous videos, static variable and non-static variable, and that videos also there, execution flow, static variable execution flow, and non-static variable execution flow also I uploaded. Please go through that videos. You guys can understood the whatever I am going to explain easily. Okay. Then I'm going to start. PC register. What is the PC register? I'm showing you one diagram. I 1 minute. I have to download from that internet. This is the. This is very good. In the stack frame, I told you stack frame. Uh, I explained previous. Main thread is there. In this main thread, how many methods are calling? Those many stack frames are creating. But here in multi-threading environment, you can create the thread like that. Thread 1, thread 2, thread 3, thread 4, thread n. Okay. In this thread also, stack frames are creating like. If you are calling method, stack frames creating like that. Okay. Then how it is going to execute this threads, thread 1, thread 2, thread 3 in this PC register. Mean program stands for program counter register. Whatever this thread 1 program counter mean this address, thread 1 address is stored in PC register for thread 1, correct na? Stored in first one. Second one is stored in PC register for thread 2. It is stored, this address stored in here. Like that, it will store like that. Each thread, it will each thread having individual address is there. Okay. What is happening here? It will PC register. What is the purpose of PC register? PC register is store the address of current execution instruction. This PC register track the thread execution. Okay, it will track the thread execution. Once this thread execution is completed, it will increase the count and then execute the second thread execution. Okay, then I'm going to explain again. Just three. Store the address of the current execution instruction of the thread, and obviously each thread has separated PC register, correct na? I already explained each thread has separate PC registers is there. Okay, that's what I'm going to explain. Each thread having separate PC register counter is there, correct na? This one thread 1 PC register stored in here, thread 2 stored address stored in here. But it will, what is the purpose of PC register? It will store the PC register, thread 1, this thread address of PC register stored here, and track the thread execution only. Okay, that's what I'm going to explain here. Then fifth one is the native method area. What is the use? What is the use of native method area? It is used for storing information about the native method. But these native methods are written in C++ language. But we should not write, we cannot write in core Java. Okay. These native methods are written in C++ language. Okay. What is the native method area? Used for storing information about native methods. Okay. Then, first one is completed. Second one is already we discussed. 1 minute. My cursor. Okay. This is the runtime data areas. Runtime data is the method area is there. Second one is the heap area. Third one is the Java stack area. Fourth one is the PC register. And fifth one is the native method stack. What is the use of native method stack? Whatever loaded byte class that store class level binary information, including static variable. Okay, we can say this is the class level binary information metadata. Okay, then second one is the heap area. Heap area, it is used to store objects only. In this object, we can store non-static variable. Okay. Then third one is the local variable which are present inside any method. I told you Java stack frames are one definitely Java stack area. It will create the main thread. Okay. One main thread definitely it will create. In this main thread, if you are calling method, how many methods are calling? Those many stack frames are created in Java stack area. Okay, this Java stack area, if local variable is there, it will stored in stack frames. Okay. Then fourth one is already I explained each thread has its own PC register, a PC counter, a PC program register counter is there, which store the address of the currently execution instruction. Okay, this PC register stored in separate thread. PC register stored in each thread having separate registers is there. Okay, it will consist of address of current execution instruction. Once instruction execution is completed, automatically PC register increment to perform next instruction. Correct na? Once thread execution is completed, once thread 1, thread 2, thread 3, I told you already, this thread 1, thread 2, thread orders n is there. Correct na? Once the PC register execution is completed, increase this thread PC register counter and execute the next PC register next thread. Okay, this is the process. Then finally, it contain native method stack. It contain data about native method. Native methods are method that are not written in Java. Correct? This is not written in Java, but it can be written in C++, depending on the operating system that is used. Okay. Then execution engine. Execution engine contain interpreter is there, JIT compiler is there, garbage collector is there. Okay, we will discuss now. We discuss class loader subsystem and runtime data area also completed. Now we are going to discuss execution engine. Okay, what is the purpose of execution engine? Execution engine is responsible to execute the loaded bytecode with 1 minute. What is the purpose of execution engine? Execution engine is responsible to execute the loaded bytecode with the help of interpreter and JIT compiler. Correct na? But what is the purpose of execution engine? First it will load the class and it will stored in that bytecode is stored in memory area. Once stored in memory area, what is the stored in static variable and object creation and executing method area, and it will track this PC register. You can track the thread and it will stored in native method. Correct na? Native method stacks are stored in stack frame, stored in native methods only. Once class is loaded and storing is done, then this bytecode execution is execution engine. What is the responsible to load responsible to execute the loaded byte code with the help of interpreter and JIT compiler. This byte code is executed with the help of interpreter with the help of JIT compiler. Okay. Now we have first one is the interpreter. Interpreter is used to responsible to execute the Java byte code line by line. Interpreter, how it is going to execute Java byte code line by line. What is the problem? What is the problem, interpreter? If so many methods are same method, we have to execute multiple time. That time it is slow down. Correct, na? Interpreter is going to slow down. That's why this is the problem. Okay, multiple time we have to execute it. The problem with the interpreter is it interrupt same method code multiple time if the method respectively called inside main thread. Correct, na? That's what I'm saying. JIT compiler. This overcome this problem, the JIT compiler comes into picture. This is the version Java 1.1 version. This comes into, okay. It will compile the method and convert to machine code. Later onward, what is the purpose of JIT compiler? JIT compiler compile the method and convert the machine code. Okay. Later onwards, whatever the once convert to the machine code, what will happen? Later onward, JVM will use converted machine code. Okay. Then note, for each method, JVM will maintain counter. Each method JVM will maintain counter. Counter will start from 0. If counter number reaching to 3, it will store the machine code in JIT compiler. Okay. Then garbage collector. What is the use of garbage collector? It destroy unreferenced object from heap area. What is the use of garbage collector? It destroys the unreferenced object from the heap area. Automatically free the memory by removing the unused object. Okay. What is the responsibility of garbage collector? Garbage collector, if your once unreferenced variable object is there, it will destroy the garbage collect. Internally, garbage collect internally calling finalize method. Okay, it will, what is the use of finalize method? It will free up the space. It will, what are the database connection? Okay, what are the database connection is there, right? We can. Okay, that is the one when we'll discuss later. Garbage collector will deeply. Now you guys keep in your mind what is the use of garbage collector. Garbage collector, it is garbage collector destroy the unreferenced variable object from the heap area. That is, you guys can keep in your mind. We will discuss later. Now what is the interpreter? Interpreter is used to responsible to execute the Java byte code line by line. The interpreter, second point, the interpreter may be slow as it convert line by line. Why it is slow down? I am telling it convert line by line and also interrupt the same method multiple times if those methods are used again in main thread. To overcome this problem, JVM compiler is used parallelly with the JVM interpreter. Okay. Then what is the use of JIT compiler? It will compile the method and convert the machine code, and later onward, JVM will use this converted machine. Okay. Already I discussed. What is the garbage collector? Garbage collector is responsible to identify unused object in heap area and destroy. Okay. Internally, it will call system.gc. You can call, okay. What is the Java native method interface? Okay. Just see Java native method interface. It hold the native method information. It hold the native method information. What is this native method library? Java native interface and native method library. JVM uses Java native interfaces to communicate with the native method library, which usually have method written in C++, depending on the environment. Okay, not much to discuss this one. Okay, now what is the key point? Already I explained clearly. Can we revise now? What is the use of what first? It will load the. I'm going to revise again. Please keep in your mind. Whenever dot class file is loaded into JVM, whenever dot class file is loaded into class loader subsystem, it will verify. 1 minute, guys. Whenever just see, whenever class is loaded into JVM, whenever dot class file loaded into class loader subsystem, this class loader subsystem, it will three activities is there: loading, linking, initialization. Once class is loaded into once class is loaded into class loader subsystem, it will check whether dot class is whether correct or not, structure like format is correct or not, valid or not, and also verify. Okay, then it will prepare the all non-static, all static variable, allocate the default value, and also and third step, you can initialize the static variable initialization and static block execution. And once this step is completed, then comes to the runtime data area. First one is the class loader subsystem. Class loader subsystem you can load and it will verify the dot class file and initialize the static variable and allocate the static default variable and initialize the static variable and executing the static block execution. Okay, then runtime data area. Runtime data area is a method area is there. Method area you can store the store the class level binary information including static variable. Okay, then heap area you can store the object inside object you can store the instant variable. Okay, then third one is the Java stack area. Java stack area one main definitely it is going to execute the main thread. In this main thread, we can how many methods are calling, those many stack frames are creating. Then the stack frames are I told you the local variable which are present inside any method. Okay, then local variable are stored in stack frames or main thread. Okay, in this main thread only it will create any stack frame. Okay, the PC register. What is the use of PC register? It is used to track the execution of the thread. It will track the thread execution. Okay, the native methods are stored in native method. Okay, it is not written in Java. It is written in C++ language. Okay, then execution engine. It is responsible to execute the loaded byte code with the help of interpreter and JIT compiler. Okay, what is the interpreter? Interpreter is going to execute a line by line with the help of JIT compiler. Okay, what is the purpose of garbage collector? Garbage collector is used to responsible to identify unused object and destroy the object in heap area. Okay, then once it destroy the object, it will free the memory and send to the JVM. Okay, you can utilize that memory. Okay, Java native method it will store the information, native method information. Okay, then what? Key point. What is the key point? We have JVM does three steps to execute the Java program. Okay, what are the three steps? There are loading, storing, and execution. Just remember there are three steps: loading, storing, and execution. And these three steps are done by who is done by class loader and class loader and memory area and execution engine respectively. Okay. Uh, Thank you guys. Please like, share, and subscribe. Okay.